My name is Bianca Lemke and I'm a Ph.D. student at the Julius Wolf Institute of the Charité in Berlin. And we have a cooperation project with our external project partner Cellbricks. And we are here with our project 3D Space Patch. We have a stereolithographic 3D printing system which works well on Earth and in normal gravity, but now the question or the task is basically to develop it further to be able to apply this kind of 3D printing system in microgravity and especially in printing biological structures. On Earth we can build with the 3D printer more biological relevant and more realistic environments and organs, and for example so that we have models, for instance, of diseases and can put more and better research to those diseases, and in the end hopefully then also print organs for people and patients in need. Stereolithographic bioprinting works with a bath of ink, and so the challenge is that the ink is liquid and it would flow then in all directions under zero gravity conditions. So we try to further develop the system to have it like really contained and to solve that challenge. One of the biggest issues in long-term spaceflight is actually the medical treatments, because astronauts cannot simply come back to Earth in time, but they have long flights, and so we need to further develop medical treatment in flights and also for different diseases, for example for burns and skin conditions, and this is basically what we are aiming at. On one hand we would like to test and develop the printer to be able to print in zero gravity and then print a wound model or a wound patch that then in the long term an astronaut can apply to his or her burn wound once he or she gets wounded. Targeted patients could be the astronauts on their way to Mars or potentially also to other planets, we don't know yet, but also, for example, astronauts on the moon base. So we are now planning the lunar base. Also, those people could actually be then targets or patients for those kind of therapies.